Let's look at the second in the list, accelerometer. Accelerometer is a sensor that measures acceleration. Basically, we're sensing more or less the same gravitation. An accelerometer would be a sensor that allows me to understand changes in velocity. Instead of getting too much to the background of our high school physics, let's start with playing with the sensor, the accelerometer sensor, using some graphical tools that we have here. So I'm hitting this tool, and now I see three bars, three graphs. The blue in the upper side of the screen, the green, and the red. And when I move it, I tend to see there's some reaction there. Now, let's leave the phone on my hand. Obviously, it moves a little bit, but let's keep it that way. And you can see that while I'm not moving it, it stays the same. But the blue line is on top of it because I have actually three accelerometers. So it's a three-dimension or three-axis accelerometer. One here, the other one will be there, and the third one there. Obviously, the blue one will be that one. And think of it as a spring, a simple spring. That sensor is being pushed downwards. So whenever I align my smartphone upwards in that direction, now the blue one, well, I'm not maybe very accurate, now moves down because this sensor now is almost not sensing any gravity because it can only move in that direction. But the green one does. So maybe so. The green is positioned that way. Now the green is sensing basically nothing. And now it senses gravity. The red would be. So you see these sensors in action actually. In that direction. Now the red is actually positioned the other way around. Positioned that way. I know it because if I twist it, back again. Yeah, now the red is upwards. So we can align our sensors, and the sensors are in kind of a rigid body within the smartphone, and having the reading of each of our accelerometer sensor, and assuming the phone is not moving too much, we can actually compute its orientation in the pitch, degree of freedom, or dimension, or the pitch angle. Think of an airplane. It has a pitch, a roll, and a yaw. So an accelerometer would help us compute the pitch and the roll. But denote that if I move in terms of acceleration, if I'm in that position or in that position, it stays the same. There's a lot of things we can do with accelerometer, and there are a lot of details. One of them is detecting maybe a bump. So consider I'm driving my car, and the accelerometer is in that position, and you can see it's relatively calm. So look at the blue dot, the blue line, sorry, and the green line and the red line. And whenever I'm doing some sort of, I bump into the, I don't know, like my driveway, and something like that happened, you see a bump. So a car might be okay with some sort of vibration, but more than that, it might break. Consider a jar of glass. It could handle, I don't know, maybe 1G, and more than that, it will break. And detecting that that impact is quite easy if you just look at that. Now, to be more precise, if I'm doing it that way, then obviously, again, we can detect the way the sensors are arranged in the phone, because if I'm moving it in that way, if I impact it from below or from above, then I see the blue line sensing because the sensor is located here. Moving it in that direction, and I see the impact. And the same with the green and the red. So obviously I do that. The red is sensitive to that, and hopefully the green, please do. Yeah, the green is sensitive to that. Right, we are kind of happy with our accelerometer, and I want to take this very intuitive knowledge and saying, okay, an accelerometer sensor is composed from 3 sensors, and it allowed me to detect, well, knowing the gravity of Earth, about 9.81 or 10 meters per second square, I can detect the orientation of my phone or my drone, very important, in terms of pitch and roll. Now, yaw is a type of measurement or physical value I cannot measure using gravity, because the gravity doesn't change if the my drone is facing the camera or I don't know, elsewhere.